Okay, so for number 27, it's asking us to find an f of t. Are you ready? 27. So it gives us a particular point ordered pair here that we can actually use to find the value of c. So we're finding a particular solution here, not a general solution. So if you needed to integrate cosine, what is the antiderivative of cosine? Sine. So this constant just remains, or the coefficient remains 2 sine of t plus tangent of t plus c. And now you're supposed to input the value of pi over 3 and set that equal to 4. Pi over 3. So this is 2 sine of pi over 3 plus tangent of pi over 3 plus c, and that should equal 4. So what is sine of pi over 3?
1/2.
Okay. Can anybody verify that? It's square root of 3 over 2? Well, what is that ordered pair that goes with pi over 3?
Oh, wait, it's the y. My bad. Yeah.
Isn't that 1/2 square root of 3 over 2? So it's the y coordinate. So it's square root of 3 over 2 times 2 would be square root of 3 plus, now tangent, remember, would be y over x.
So 2 square root of 3 over 2. Oh, wait, no. Square root of 3.
That becomes just square root of 3.
Yeah.
Because it becomes times 2 over 1. So that's square root of 3 plus c equals 4. So isn't this 2 square root of 3 plus c equals 4? So your c value is 4 subtract 2 square root of 3.
Yeah.
So that tells us that our particular solution would be 2 sine of t plus tangent of t plus 4 minus 2 square root of 3. Does that match the answer key?
Yes.
Great. So we should move on now to number 33. 33, if you notice, gives you your second derivative. And does it give us any information about the first derivative? No. So we're going to have to go ahead and integrate twice on this one, and then try to find out what our c values and our d values are. So what's the first antiderivative going to be?
2x.
2x
minus x squared
plus c. Now when we integrate this,
x
x squared,
minus 2x cubed plus cx plus d.
there you go. So don't forget that little plus cx and then plus d. So now if I input 0 into the function, 0 minus 0 plus 0 plus d equals 9. So d is 9. So now I'm going to input 2. Did I do that correctly? Remember, d is now 9. So you're putting in 2 in the place of x's. Okay, so 4 minus 16 plus 9 is (2c) is 18. So do we get c is also 9?
Yep.
Okay. So f of x turns out to be x squared. Subtract 2x cubed plus 9x plus 9. Yes, sir, Bennett?
For these problems, will it always give you one with a 0?
No, it might not. It might give you 2 of these where then you have a system of equations that you have to solve. So you would end up with something with C and D and a number, and then you could do elimination or substitution or graphing. So it will not always give you 0. So the next one that you wanted to see was 37. So when we get to number 37, it says, given that the graph of f passes through the point 1, 6. So this is a point on the graph of f. And the slope of the tangent line is 2x plus 1. So doesn't that mean my derivative is 2x plus 1? They're asking me to find f of 2. Well, before I can find f of 2, I need to find a particular solution for f of x. So if we integrate x squared plus x plus c, now input 1 and your output should be 6. So 6 should equal 1 plus 1 plus c. Doesn't that tell us that c is 4?
Yes.
So our particular solution says that f of x is x squared plus x plus 4. And then take it one step farther and find out what is f of 2. 10? Because you're just going to input 2 into that particular solution. Now we'll go with number 39. So which graph is the antiderivative of f? So that would mean they're asking you that f is the derivative of which one of these, correct?
Right.
Okay. So if we're thinking of f as being the derivative, isn't it negative between here and here? Which would mean my original graph would have to be doing what between here and here? Decreasing. How many of those graphs are really decreasing from 0 to this value? Only one. So the correct answer is B. Okay, and then for number 41.
What are those crazy graphs in 47 and 48?
47 and 48, these are called slope fields, and it is a very simple topic, and we'll just get to it right before the AP exam. Because I saved some of those really easy things right before the exam so that you'll remember them exam day. It's not bad at all. So really, it's just showing you what the slopes of the graph are at every location. So do you see hidden in here like a certain shape? Like it goes up, it levels out, it comes back down, it levels out, it goes back up?
Yeah.
So what happens is you have like sort of a ghost image hidden in there. These are all the slopes, but you can actually see what the original function was. It gets steep and then levels out and then comes down and then levels out. So we'll get there. These are all the slopes, and hidden in the slopes would be the antiderivative, the original function.
Wait, so how would the 48 look?
48, a lot of times it depends on where your initial position is on the graph. So they would give you a point to start at. So if they said start here, then it would sort of go like this, and then that gets possibly vertical. Maybe not. Then it levels out, comes here, levels out, goes like that. Ish. Okay, so let's look at number 41 will be our last question. Make a rough sketch of the antiderivative f given that f of 0 equals 0. So that means you're going to start here. Doesn't that mean that this red graph is the derivative of what I'm drawing?
Yes.
So my derivative has what sign here? Negative, which means that my original graph would have to be decreasing. Okay, now, is the derivative of this red going to be positive or negative? Positive. That means the second derivative is positive, so it's concave up and it's decreasing. So the original graph needs to be concave up and decreasing until I get to 0, 0. Then doesn't my graph start to increase?
Yes.
And my graph is going to continue to increase until I get to an x value of 2. When is it going to be increasing most rapidly?
Like right. Oh wait.
At the...
Yeah, at 0 pretty much.
Nope.
It's like
At 1?
At the maximum? Isn't that where your slope of your original function will be the highest? Yeah, because right now the slope is 0, which means it's flat. Then the slope, like here is some value, isn't the slope going to be higher here and higher here and higher? It's going to be most steep right here. So it's going to continue to increase, but now what's my concavity going to be? What's the derivative of this red graph? positive,
So it'd be concave up.
so it's concave up, and it's still increasing. So it's concave up, and it's increasing most rapidly right there. Then it's still going to increase, but now the concavity is going to be
Down.
concave down, and now it begins to increase less steeply until I get to 2. And what should happen at 2 on my original function?
It should start decreasing.
It should change from increasing to decreasing. Our graph should have a maximum value at 2. And so now this derivative is negative, which tells me that my original graph has to be decreasing. So my graph is going to decrease from 2 on. But the derivative of this is what sign? Negative. So it's going to be concave down until I get to right about here, correct? Okay, so it's got to be concave down until I get to about there. And then it's going to change because doesn't this increase slightly? So now it's going to continue to decrease but be concave up. And so that's a picture of what the original graph should look like. Okay? All right, Wyatt, can you stop that for me? Wyatt?